So hello everyone. Thank you for being here with us today. We're really excited to have you here. Over the next 45 minutes, we'll be diving into how leading manufacturers are using Knowledge Graph Rag to transform things like SOPs, QA, and inspections. You'll see some live examples, hear from engineering leaders, and hopefully walk away with the new system on how you can implement AI into your organization. I'll go over brief logistics, housekeeping before we get started. This Zoom will be recorded. We'll be sending out a link to everyone after. Everyone will be muted, so no worries there. For questions, use the Q&A box, and then for comments, you can use the chat feature. And then at the end, we'll save time for Q&A to dive through all of them. We'll have some of our engineers answer some of the questions, and there'll be time at the end for that. So for the agenda today, we'll start with a brief overview of webAI. We'll dive into why we're here and why this matters now. We'll take a look at real-world impacts in manufacturing and aviation. From there, we'll dive into how Knowledge Graph RAG actually is working behind the scenes. And then there'll be a next step on how to get involved, and then the live Q&A. So, what is webAI? At the highest level, webAI is a platform of private sovereign AI. It lets organizations train, launch, fine-tune, and deploy models fully locally within your own infrastructure. We're not chasing generalized models. It's a one-size-fits-all models. You can actually build specialized context-rich models that actually fit into your business. We just did Series A last year, 2024 in September. We're based in Austin, Texas, and we're growing and hiring all across the US. To give perspective, I was the 50th hire, and now we're at over 120, and I started in January. So if you know anyone who's looking for a role, wants to dive into the AI space, wants to be a part of an amazing company that's growing fast, feel free to check out our careers page. We have a ton of opening roles. We have customers across different industries, from aviation to fintech to manufacturing to healthcare to biotech, the public sector. Some of our notable customers that are publicly are Aura Ring and Divergent Technologies. We have a few financial institutions across APAC and one of the largest airliners in Asia Pacific. So the speakers today, I'm Josh. I'm the Senior Growth Manager here at webAI. You'll hear from Hossein, the VP of Engineering, Pavan, AI Software Engineer, and Keith, a Sales Engineer. They'll all be diving into specific categories. From here, I'll pass it to Keith. He'll dive into what what RAG is and kind of why we're here today.
Yeah, thanks, Josh. I really appreciate it and really excited to be here. Before we get into the demo, just wanted to spend a few minutes and explain to you our vision for AI and some of the background that you're going to see today for what we've built. So our vision for AI is very different than that of what you're probably familiar with, the frontier models and these massively large LLMs that are just ever growing in knowledge and size. Instead, we believe really the future of AI is billions of models that are purpose-built, use case built, that are connected together, working together in a meaningful way, and most importantly, that are owned by the people that create them. Next slide, please. So why does billions beat one, right? This is really a story of less is more. So because we can take a much smaller model and either augment it with data or fine tune it, we can bring down that size and focus on purpose use case built AI. And those models can be incredibly small. They can run on your laptop, on even end devices, on infrastructure that you manage and control, can be in the cloud or on premise, of course. But that is the real value with regard to that. And so it unlocks different economics. Instead of paying a flat token rate, you can really focus on a different economic model for different use cases, depending on the AI that you're building. And then finally, since you're creating the AI, you actually own it. It's private and secure. It can be in your four walls. It can comply with your regulatory needs and meet your compliancy. Next slide. So web AI, we're really focused on building a platform that allows you to create these expert models and connect them together in a meaningful way on the infrastructure of your choice. And then, of course, all of this is sovereign by design. Next slide. And so we're focused on a broad range of use cases, not just what you're going to see today. So wanted to just introduce some of that. On one side, we have, of course, federated and private AI. It's a huge area, and there's a plethora of use cases there. But we also focus and tailor on vision use cases and even on the edge. So if we consider manufacturing, assembly line, parts being built, repair, engine repair, even in airports, baggage, figuring out what needs to go on the plane. These are all vision use cases where we can use object detection, where we can use image classification, and really build intelligence around the edge, and do so while maintaining, of course, privacy and security. And then finally, we get into predictive anomaly detection. So this is really machinery that is emitting sensors where we're using that data and leveraging AI to make predictive decisions about what we should do. Should we is the machine going to break soon? Does it need maintenance? What should we do? And so really helping in those areas as well. Next slide, please. Today, of course, we're going to focus on a very critical use case for us, which is this multimodal knowledge graph RAG. Next slide. And so the reason why have we built KG RAG, as we refer to it, if you have worked with RAG systems before, you've probably come across the shortcomings, and that is because RAG relies on flat text embeddings in a vector database, meaning is lost. So while it does a great job, if you give it a book and you start asking it questions about that book, it can use semantic search and come up with very good answers to that. But if you give it more complex data, such as manuals, like an airline manual or some kind of machinery manual or scientific data or graph data where you have XY axis, complex data that has meaning, either where different pieces of text have meaning that needs to be captured, or we're dealing with tables, we're dealing with graphs, scientific data, images, where the meaning is not obvious. And so that is the piece we really built around the retrieval augmented system, is this knowledge graph using nodes to capture the meaning, so it does not get lost. And so we can present that to the LLM, and so we can increase accuracy dramatically for these complex type of documents. And we've actually proven this ourselves. If you're familiar with robust QA, it's a benchmark, and we basically shattered the previous results with a 94% accuracy. You're going to see this, you're about to see this, but we go a step further because we also want to make sure that it's safe and that outcomes are reliable. And so we are getting into explainability and traceability. And so we provide the sources actually for where we got the information. And so you can actually fact check the LLM in real time if you are concerned the answer may or may not be accurate. Where did it get this data from? And at this point, you're going to see all of this live. So I have the pleasure of handing you over to Hoss, who is our VP of Engineering, and he's going to show you this now firsthand. It's all you, Hoss.
Thanks, Keith. All right. Let's start with an overview of the platform and what we are building. So what we have always focused on is bringing compute on edge and on-prem AI easier and make it more user-friendly, and something that a lot of the people across the board in an enterprise setting can work together. And our main product is called Navigator. It's the app that you're seeing in front of you. And what it enables is basically one place to control all of the projects that you do have. And the approach that we have to it is a very modular, and customizable way to do AI. This is our homepage. We have other tabs that we can go to. One of the settings that we enable is clusters, which is if you have multiple machines within your network, we would enable you to use those computes together in a distributed way. So if you have a model that's too large and doesn't fit on a single machine, you can create a cluster of multiple machines and distribute the model among them. The tech is called WebFrame. There are benchmarks out there on how we are performing in terms of accuracy, performance, tokens per second, and time to first token among those. So there's great performance there as well. Other tabs like deployments, we will get into in a bit, and the AI models, which is a list of models that our platform supports. A lot of the open source models are supported within our platform. Let me show, if you get into our platform and you want to get started, there is a bunch of templates that we have previously got ready for people to interact with and build from. One of the use cases that we want to talk about today is KG RAG, but we also have a traditional RAG pipeline. I can open this template just to get a feel of how the platform looks like. As you can see, every piece of it is a modular, and what we call these is templates. All of them have the settings and the customizability that you want. Let's get to why we are all here in this webinar today and get into our KG RAG. This is our KG RAG pipeline. You have the document, and it creates a knowledge graph. And our approach to this RAG solution is a graph-based RAG. And I will show the document that you're working with today. It's a mill operations manual, but it has automation. It's 550 pages of document. And after doing the ingestion, what you will get is a graph that shows the relations between different nodes that you have in your document. And we use this information, the relation between the pages and nodes and all of the information that you have inside your document, figures and tables and all of that, to get you an accurate result. One of the things that's very important to mention is that this document is a very technical document. Let's go to the inference part. After we are done with that ingestion part and create the graph, we can use the same graph that was created and how we ingest the document to interact with it. And we are going to be using our knowledge graph retrieval and the API that we have and an LLM to chat with the document. Let's go through the document. As I mentioned, this is a very technical document. It has a lot of, this is the beginning of it, but it has a lot of tables, figures, and this is something that large language models are struggling with. They are very good with if the document is all text, although the RAG would still be a superior way of doing those as well. But with these documents, very technical documents, they struggle. In this page, we have this figure here, and let's say that I'm working with the machine, and I remember that I had two things. I had a-axis scale, and I had the axis power, but I don't remember where they are located. I remember that I had both of them, and as you can see, they are stacked on top of each other. So let's ask, is a-axis scale above? The other one is a-axis power or below it. Right, in a second, our system is going to go through the document and find the correct answer. See, it came back, gives us the whole, we've got the information and how it's detailed. The conclusion is that a-axis scale is above a-axis power. One thing that's very important in these settings is to be able to verify that the information is correct. And as Keith mentioned, we give you sources. Let's click on the source one. It exactly pulled out the page that we had the question from. So it enables a human in the loop to be able to verify the answer that you are getting from the LLM as well. So the worker that's interacting with the machine can, instead of going through the document that's hundreds of pages to find an answer, get an answer from LLM and verify the answer as well. Let's go back here and let's go back to the document, scroll through it. As you can see, a lot of technical image diagrams and tables. Let's go through, see what else. Okay, I see that this machine shows me a lot of icons and informations on its screen. Let's say that an icon pops up. The first one, the light curtain breach. I am not sure what it means. Like there, as you saw, there are a lot of icons that come up, and sometimes you might forget. So let's ask, what does icon mean? All right, let's see what's the answer that we're going to get and if it's going to match the document. The light curtain breach, let's see, I can put them side by side, is triggered when machine is idle and light curtain is activated to also have when program is running. So we are seeing that the information matches what we have in the document. Again, we can verify with the sources. Let's see what's link 1. It's the same page that we got the original question from. This is not pulling the page from what I was showing. This is actually going through the document and it's retrieving the exact correct page. Let's see what link 2 is. Link 2 is, okay, yeah, it's light curtain enable and it has some more information. So it's, although it's not directly the question that we answered, but it's giving us the information that's relevant to that one as well. One other feature that I wanted to show you, and it's something that we are developing internally right now, and I said that we'll come back to deployment, is that you can take the canvas that I showed you and deploy it. And what deployment means is that it gives access to other devices that you might have within your organization or in your network. I will use the screen mirroring and pull up my iPhone, and let's go back to this one. And yeah, so as you can see, it shows the deployments that I have, and this is the KGRAG mail operation. And let's ask the same question here. What does While we are getting the answer, I need to mention that this is not running on the iPhone. The iPhone is connected to the deployment through a peer-to-peer communication, and it's getting the responses by model running on the studio or on the compute that you have. And it gets the same information. Let's see if the answers match. As you can see, it's giving us the exact same information. So if you have your iPad or iPhone on the factory floor, you're not walking around with a Mac Studio, obviously. But if you have the device there, you can connect to that deployment that's running there. And yeah, this is walkthrough of the document of the demo that I had for you guys. I'll pass it to Pavan for more information on KGRAG and a deep dive. Pavan, all you.
Yeah. Thanks, guys. Yeah, so as Hossein mentioned, we have the ability to run these models on the device and then share it across a network of endpoints that you can basically configure to run on an iPhone or an iPad. So for this part of the demo, we'll go over the F-18 flight manual. So this is basically by the Navy SEALs. They have made this public. So you can imagine equally private document which has like all of these details on basically how to operate the aircraft, what are the specifications. So you can see that this has the sort of manuals to maintain as well as inform the pilots on the aircraft itself. So let's start with this flow. This is the same flow that Hoss was sharing. We have already completed the ingestion part, and we have the flow ready to go, and we can ask it questions here. So just to understand this document, so you can see it's almost a 900-page document here. And then if we want to ask it specific questions, just to get an overview of the entire document, I can ask it maybe what are the different variants of the fighter aircraft 18 described in this document. So right now, this is a model running entirely on my machine, and we are able to see the analysis as well that the LLM does, along with the context that we have provided it. So it says that it describes the B and D variants, and if you want, we can also look at the cited pages. It mentions what are the specifications for these aircrafts. So it has the B and D variants. Now we can ask it some questions like what are the key specifications, that is the length, weight, and wingspan.
Hey, Pavan.
Yeah.
I don't think we were able to see the document. Were you sharing the window or the screen? We just see Navigator.
Okay, just give me a second. I'll just share my entire.
Yeah, I think
Yeah, sorry about that.
900-page document's pretty impressive.
Yeah, sorry. Yeah, so it's a 900-page document that you see here. Yeah, so this is the Navy SEAL manual. And then you can see it's almost 900 pages here. Yeah, and it describes the A, B, and C. So let's start that from the top maybe. So I can ask it what are the different variants of the FA-18. Yeah, so it shows that all the A, B, C, and D variants are described here. So you can see that is exactly what the manual suggests. And then if I bring in the cited images, it sort of looks at these pages that are existing within the manual. And you can imagine a similarly complex manual, which you don't want to basically query public LLM. You don't want to send that information across. So you can run it on a private manual as well. So we can ask it things like, so what are the different angle of attack indexer modes? So this basically shows what are the different angles of attack that are supported by the different variants for these flights. So yeah. Yeah, so you can see that it sort of gets the angle of attack indexer, the specific pages for where these angle of attack is mentioned and also described. So it gets that, and then we can ask it something like, so we can ask it a general question where the information is not readily available. So what were the upgrades introduced in the FA-18 CD version variant compared to the FA-18 AB variant? So it analyzes this document, tries to find the relevant pages, and if the answer is not directly discernible, it says that it's able to glean that based on the specific pages that are mentioned here, it's able to find the differences between the specific versions of the aircraft. So the A and B as well as the C and D variant, And then, yeah, so it's able to analyze these technical differences. And then if you look at the answer, it says that it has some canopy bird strike resistance, the control display, which is the software updates, which occurred for the B and C variants. So yeah, that's pretty much similar to what you saw with the manufacturing use case, but in a aviation use case where you're dealing with very technical informations described in images, figures, tables, and so on. And we can maybe dive a little bit deeper into the architecture. So is everyone able to see the screen? Yeah. So how we thought about KG-RAG is essentially, as Keith mentioned, instead of using flat text embeddings, we wanted to figure out how all the figures and tables that are mentioned can be analyzed by a VLM or a LLM. So first, we begin with the document ingestion phase, where we take a technical PDF, we extract the metadata, which is basically the page numbers, the figure names, the table names, and the references to each of those. And then we chunk it accordingly. Basically, we figure out what the, each paragraph which represents a certain entity or a specific piece of information. And then we extract chunk level embeddings. And these are considered as nodes when we add them to our graph. So as you know, like graphs are made of nodes and edges. So first we extract these nodes, add some descriptive information, and then we add edges based on the reading order, like chunks which are logically in the reading order will be related to each other. And then there'll be some semantic relationships. So you saw in the cited documents that some of the previous pages will be referenced by future pages in the document. So those are considered as well. And then we also have the references to sections. So this includes things like figure 219. If it's mentioned in the document, it will basically add edges between those chunks. And then we add that into a vector database. So in order to convert this text as well as visual information into a vector of numbers, essentially, we use a embedding mechanism. So we try both VLMs as well as LLMs, depending on the type of information that we are embedding. And then we add that to the vector database. So that completes the ingestion part. And then once the user starts with a query, we first embed the prompt as well using the same models that we used for ingestion. And then we extract the relevant context. So once the user submits a query, their prompt needs to be processed, which is essentially converting this prompt into embeddings, doing a similarity-based search in the vector database, and then adding the relevant context as well as the metadata so that we can get some of the citations as well. And then we add some system prompts to make sure that the answer is relevant and based off of the extracted context. So we add all of this and present that to the LLM or the VLM. You can choose which model you want to run on your machine. So you can choose that. We have a modular flow like Hoss mentioned. And then the final response is essentially like summarized, provides like a detailed analysis of what pages it basically went through, what figures it went through, and then we are also able to see the cited images. So that sort of like covers like the overarching architecture of the entire flow. And you can imagine that this architecture will scale as LLMs and VLMs get better, and the added security aspect of running all of this on your hardware. You own your data, you own your hardware, and you own your models. So we allow access to a plethora of multimodal as well as text-based large language and vision language models. And then as they get better, you can pull in the latest ones and then deploy your RAG pipelines on this. So yeah, that's about it from my end. Thank you, guys.
Thanks, Pavan. It's really cool how you dove into it, show the really large document. Let me share my screen. Okay, so if you guys liked what you saw today and you think this is to be implemented into your organization, you want to take a next step, we do run a private hands-on workshop with our engineers. We sit down with you and your team, your data, your workflows. It's a 2-day workshop. Day 1, we'll explore opportunities. Day 2, we'll prioritize and shape real use cases. You'll be able to walk away with a clear roadmap, blueprints for 3 to 5 use cases, and a plan to move forward. I'll drop the link here in a second if this is something you're interested in. I have a few more places available. And then I saw there were quite a few questions in the chat. We'll take time for our engineers to dive deep into them, and some were some pretty technical questions. Let me drop the link into the chat really fast for everyone. Carson, are you able to drop the link for people, if you don't mind? Okay, here we go. There's a form if you want to fill out to explore what a 2-day workshop with our team would look like, where we dive into your data. Take a few minutes. It will be emailed after, along with the recording. In the meantime, we could dive into the Q&A. If Hoss, Keith, Pavan, if you guys are able to see the Q&A, there were some pretty good questions in there.
Yeah, Carson, do you want us to go through the questions one by one, or do you have ones selected?
Yeah, so let's just start with in order of how they came in.
Yeah, for sure. Okay, so there's the first question is, do you guys have one or more custom dedicated embedding models? So as we mentioned, the models that we do support on the platform are the open source models that we use. And for the RAG specifically, we are using the embedding models and the whole system that we have to create the graph and the relations between the nodes and the data that's inside the document. We are not using any custom embedding model at this point. Yeah, Pavan, is there anything else to add on top of that?
Yeah, so we have tried out a few of the open source models as well as some of the licensed models, and like from what we have noticed, the closed source and licensed models perform as good or a little bit worse than the open source models that are out there. So yeah, like especially for embedding, I think there are newer models which are coming out, which are open source by Google, Meta every day. So yeah, recently they released one that fits on mobiles. So yeah, I think the open source way is much more accessible. So yeah, we have chosen the open source way for this as well.
Yeah, there were a bunch of benchmarking that we did, and the model that's selected by default is the one that's performed best. Obviously, like as I mentioned, there are a lot of settings that you can play with in the app, and if you want to choose a model that would be working better for your application, the user would have the control over it. The second question is, curious if you have standardized templarized knowledge graph schemes. So how we build it in the platform, we have templates for it. And like the whole thing is custom against the document that you are bringing in. So it ingests the document, and the graph that you see, every graph is for the document or set of the documents that have been ingested. So the graph is always unique to the information that comes in. But to make the ingestion pipeline and like the inference part of it as streamlined as possible, it's something that we have in the platform.
Yeah.
The next question is, do the ingestion pipelines and graph schemas account for images and graphs? How do you know that it references the document as opposed to just presuming because it's above other entry on the list? I'm not sure I'm understanding this question clearly, but I will answer to the best of my knowledge and based off my understanding of the question. It is using everything that's inside the document. It's using the tables, it's using the images, and I think the answer about the question about the using the one that was above other entry on the list, I assume it means the icons. We can try another one here. Again, going through the icons, let's choose this one. What does?
You want to share your screen or?
Oh,
And I think that question might have come in before you started demoing, but we can show another if you want.
oh, okay. Just me. There we go. I think now we are the whole screen, right?
Yep.
Yep. So I chose this one in the icon list, and it says that indicator for location system, and then let's see the links. It's this one, link to, yep, it pulls from the same page that we got the question from.
Oh, he clarified on the question.
Yeah, I see a question about what information pilots have found the need to look up mid-flight. So, yeah, I think this is not for pilots to look up mid-flight, right? Because again, like those pilots are highly trained. This is more for pilots who are in training. So if they want to basically glean information without having to basically sift through the index and find the relevant page, it sort of allows them to find what they need and figure out which pages they need to reference. So yeah, this is more for the training aspect and not mid-flight. And yeah, like they will already have a lot of comms mid-flight, so I don't see how they will integrate RAG running on their model device. But sure, like if another use case which is similar is basically flight attendants, if they want to check if a goods can be taken on an aircraft or not. So that's something else where the manuals will have that information, but mid-flight, if they don't want to connect to the internet, you can have a small Mac Mini running this model locally, and they can access these models through iPads and then ask it a question saying, can they bring this on the flight and add image. So we are also supporting multimodal queries. So we are working on that, and it will basically allow them to in real time check whether a certain goods can be taken on an aircraft. So I think that was Stuart's question, or I think Kyle Clark has asked that question. So I hope that's informative.
I think Stuart was trying to raise his hand. If you guys want to, he has a few questions in the chat. If you guys can take some of those.
Yeah, there are a couple more questions on the chat that can a KG-RAG have multiple documents and build a model for these as a library of your knowledge? Yes.
Yes.
So it's not just a single document, but also like if you have multiple documents, it would build the knowledge graph based on the collection of those documents.
Yeah, and we also allow users to select whether they want to create relationships between documents, because sometimes when you create these knowledge graphs, we want to keep specific manuals regarding specific aircrafts or specific equipments separate, so that you don't accidentally form links between them and sort of retrieve like the wrong context. But that would really depend on the type of documents that are being ingested. So coming like the document manager, where you essentially want to create inter document relationships or not. So that is a feature that is already in beta, and we are testing that to publish that to our clients as well. So yeah, the allowing inter document relationships or not is a user's choice, and we're providing that.
We've got a few more minutes if we want to rapid fire through some, if possible.
Yeah. So I'm not able to see all the questions. If you can maybe pick a few which are at the top. Yeah.
It's like, is the companion for iOS available? Keep an eye out for upcoming news. Not right now. It's how do you have a TCO ROI comparison cost to GPT or Gemini? Josh, is that something that you can answer?
We have a cost calculator that I can provide. Stuart, I'll follow up afterwards with, I'll follow up to see if we have any specifics on those.
What is the key difference between the RAG and the KG-RAG? Can you describe in a single word? I think it's a little bit more than a single word. The KG-RAG is basically a graph-based RAG system that we have developed. It's still a RAG. The RAG is usually referred to as a vanilla RAG, which is the simplest form of the RAG. They are very basic. They do chunking based on the number of tokens and all of that, and are not very accurate. Was there any model compression performed on the open source models prioritizing edge deployment? Yes, that's a very great question. We do provide different quantization of the models in the platform, and we have a technology called EWQ, entropy weighted quantization, which dynamically quantize the model based on the device. So it prioritizes the layers that are important and keep the quantization as high as possible, and then the ones that are less important would get quantized further, so the model size shrinks. And we showed in the benchmarks that we can shrink the models up to 30% while keeping the accuracy the same.
Yeah, just to follow up on that, I think Kyle's question is coming in as well. So yeah, we have a paper out there. So if you just search EWQ webAI, you'll probably find it. But yeah, so the difference there is between fixed precision quantization, where you're quantizing all the layers and all the weights with a set precision, like int 8 or int 4. But in EWQ, you look at how much each layer or each weight sort of contributes to the entropy of the outputs. And then based on that, you can figure out which layers are important and which weights are important, and also take into account the amount of RAM available. So as long as you want to fit a model on the device, we can figure out like dynamically which precision needs to be applied to which layer, and then yeah, use that data to basically quantize them with the dynamic precision, not fixed precision. But yeah.
Do one or two more and then we'll close out. Open up the
I'm
Q&A.
wondering how well it works if I have thousands of manuals for different devices and want to look up information about a specific one. So as Paul mentioned, there are different ways to do this. Like one is from the list of documents that you have. If there's a certain one that you want to ask from, that would be one way to go it. And also you can create the relations between different documents.
Yeah. Just to add to that, so the difference between like the usual RAG approach and knowledge graph based RAG would be that you're not only getting the page which is relevant specific to the user's query, but also pages that are relevant to the pages that are specific, right? So there is like 1 to 2 degrees of separation sometimes between the important information as well as the first layer of relevant context that is extracted in a vanilla RAG. So I think that's where the difference comes in, especially in technical documents where there is like convoluted structure and semantics. But yeah.
Josh, I know we are over time. Do you want to continue going or do you want to?
We can cut it. I'm putting in the chat that I'm putting my email. You can follow up with any questions, and we'll have an email coming afterwards with the recording, a few documents, and a link to the private workshop if interested. But thank you all so much for attending. We'll be doing more of these in the near future. Again, reach out if you have any questions. I'm going to drop it in the chat now. Thanks, everyone.
Cool.
Bye-bye.
Thank you for coming.
Bye-bye.